Okay, 2.2, falling off a log. Definitely taking a jump from the more difficult today. Construct a table of values and graph each of the following functions. Be sure to select at least two values that are in between that interval of 0 to 1. F of x equals log 2x. Here we go. All right, so for our table, we're going to have x, and we're going to have log 2x. Okay? So remember with this that log 2x is going to equals the exponent, right? Okay. So it's going to be, that's actually equal to the exponent. So it's easy to get kind of turned around with these. So I remember my teacher had me write, over here, basically with these, the y is the exponent, and then over here is like the answer. So for all the tables today, and you're going to be doing a lot, if you want to use that to remind yourself, you might be happy you did so. -2, -1, 0, 1, and 2. Okay, so remember, this is the base, and then this is the exponent. So you have 2 over here. So 2 to the 2 is 4, and 2 to the first is 2, 2 to the 0 is 1. And then we've been working a lot on this. This is why we did the quizzes the other day, okay? 2 to the negative first is a half, and 2 to the negative second is a fourth. So when I graph these, I'm going to go 1/4 over, barely at all, and 2 down. Then I'm going to go a half over and 1 down, 1, 0, 2, 1, and 4, 2. And we could do one more. You could do 8, 3 as well. So here is the graph of this logarithm, okay? It's going to come up like that, all right? And you could picture the next point, right? Like 16.4 would be like way out there, okay? So it just kind of keeps going. And then you can also picture it going this way, okay? Like this is really the turning point where it starts to just get extremely close to the line. Because here is a fourth, right? And then we're going to have an 8th, a 16th, a 32nd, a 64th, 128, and we never get there. So this is going to look like a vertical line even though it's not. Okay, that gives you enough information to graph B, C, D, and then answer the questions. How did you decide what x values to put in your table? Well, Mr. Thacker gave them to me. I don't know. Why do you think I chose those? Okay. 3, how did you use the x values to find the y values in the table? And you just go through and you answer questions on all those based on the graph. So we'll pause the video here, and then we will pick up again after you answer those questions based on that. Okay, let's focus now on k of x equals log 10x so that we can use technology to observe the effects of changing the parameters on the functions. Because base 10 is very commonly used for exponentials and logarithmic functions, it's often abbreviated and written without a base at all. And it looks like this. K of x is equal to log x. Use technology to graph log x. How does the graph compare to the graph that you constructed? So here was your graph, okay? So go to Desmos, and then, well, I'll do it right now for you, but you don't need to go there at the moment. But you're going to compare what I have on there to what you graphed before. So when you're on Desmos, make sure you're on the scientific calculator, and then you're going to go functions and over to miscellaneous, okay? Now, we're going to use this, okay? No little number, because the number that's really there, as we just learned, is a 10, okay? If you want something like some of the previous problems, like you want log 2, then you're going to choose the other one, and then you can plug in a little number. That's how that works, okay? So for this, for our purposes today, we're going to go log x, okay? Which is really log 10x. And then kind of compare how does it look, and hopefully it looks, the same as what you graphed for that previous problem. And then you might pause it here and get yourself an answer to that. 8, how do you predict the graph of a plus log x will look? Okay, so this time something is being added to it. Go ahead and take a guess as to what you think that might be. Number 9, test your prediction by graphing that for various values of a. What is the effect of a on the graph? Make a general argument for why this would be true for all logarithmic functions. So we're talking about the effects of adding a on our logarithmic function. Okay, so I'm going to make sure you start bringing graph paper, but for today, I'll just go ahead and help you out here. So remember, we're talking about, log x, and we're talking about these numbers over here, but this time it's 10, okay? So we have 10 to the third, we have 10 to the second, we have 10 to the first, 10 to the 0, 10 to the negative 1, and 10 to the negative 2. Okay, so now we're kind of wondering, well, what's going to happen? All right, what's going to happen if we, they wanted us adding on this one, right? Yeah, so what's going to happen if we go like log and then x plus 2? What's that going to do? Well, it's going to go like this, okay? And I'm going to let's do 3 first, okay? So remember, this is an unwritten 10, so it's like 10 to the third, and then it's like equals, right, x plus 2. So we know that 10 to the third is 1,000. So what I need is like 1,000 over here, right? So really x plus 2, it needs to be 1,000. So x is equal to 998. Okay, if you couldn't get that the first time, maybe this one will make a little more sense. So this time I'm going to have 10 to the second over here. And I'm going to have 100 needs to equal x plus 2. Okay, so what x value would make that true? Well, that would be 98. So the question was, what effect is that going to have? Or how do you predict that that is going to affect it? So you make a prediction. That probably helped you a lot. 11, test your prediction for various values of b. That's what I just did. What's the effect of adding b? Well, it's going to move it to the left, right? Okay, here it was, and mine went left 2. So it's kind of similar to quadratics, okay? Except this time, when it's added, when something is added, like this one was added, right? It moved to left 2, like quadratics. You might remember some of that from last year. So it's sort of similar, but there's definitely some differences that you're going to want to watch out for. So the effect of adding b. The effect is to shift the graph. The unit, it shifts it. It shifts the graph left b units. What will the effect be of subtracting b or adding a negative number? Let's visualize that. So if I had subtracted 2, not 22, but if I had subtracted 2, now I have 100 equals x. What x value would make this true? Well, I would need like 102 over here, right?
Good afternoon, Westview staff. Just a reminder of our committee meetings this afternoon. Safety committee will be in the lower south conference room. Social committee in the lower north conference room. Restorative practice team in North 126. ESL success team in North 129. SPED success team and learning center in the library. Equity advisory team, North 114. Principal advisory committee in North 228. And Avid site team in North 128. Starting at 2:45. Thank you. We'll email these out to all of you in case you missed the announcement.
That was interesting. Okay. That's what's really important for that right now. I'm just going to read you what it says in the answer key for your general argument. The horizontal translation works for all functions, including logs. If b is added to the input value, then every point in the new graph will occur b units before it occurred in the original graph, thus moving it left. The reverse is true if b is subtracted from the input value. Okay, that is 1 through 11. I'm probably going to need to make another video.